Hey, this one is going out to Bomlock, who wanted me to go through a gravimetric analysis problem. And so, no big deal. If you ever want a video like just for you, all you have to do is ask. So the problem that we're going to do today, I'll read it and then I'll show it to you. You can freeze the video, do the problem, and then I'll show my strategy and my work. Okay? So when a sample of impure potassium chloride that has a mass of 0.4500 grams, which means there are 4 sig figs that we're carrying through here, was dissolved in water and treated with an excess, there's that word excess again, of silver nitrate. 0.8402 grams of silver chloride was precipitated. Ooh, precipitate, that's something we got to keep track of. What is the percent of the original sample that is potassium chloride? So we have something that is labeled potassium chloride, but man, it's got some junk in it. We don't know what it is. And so what we're going to do is we're going to isolate one part of the chloride from a sample and then precipitate it and dry it, mass it, and then figure out how much chloride we have actually to how much we should have had if it was a pure compound. Okay, so I'm going to put this up here for you to read, and then you can get what you need from it and do the problem. Awesome. Okay, so now that you've attempted the problem, here is the strategy that I have used to do the problem. Okay, first thing I'm going to do is identify the precipitate. And in this case, my precipitate is going to be silver chloride. That's a pretty common precipitate. Switch to moles. So I got to switch to moles of silver chloride. I pull out the needed piece, and so since we're dealing with silver chloride and potassium chloride, the chlorine is what I'm looking for there. And then switch to moles of the original compound. Now, I think in a problem we did for class the other day, it was just calcium, so you didn't have to worry about the whole compound, which was calcium carbonate. They just wanted the calcium in there. But this one, it wants the percentage of calcium, or potassium carbonate, so we're going to want that mass of the full compound. So we're going to switch to the mass, which is just switching it to grams, and then we're going to get our percentage. So I'm going to leave that up here for a second. You can freeze me, and if you want to write that down and take some notes. We're back. Okay, so here's the problem that I set up. And you see that it has 1, 2, 3, 4 ratios in it. I identified my precipitate. I switched it to moles. I pulled out the piece I need, the chlorine, and then I switched it to moles of what I'm wanting, the potassium chloride, and then I switched that to a mass. Okay, so I'm going to do that right now on my calculator. And I'm going to say what I'm doing while I do it. And then, let's see. I don't know if that's really going to work all that well, but. So, 0.8402. Turn on my calculator. Blooper reel. 0.8402 divided by 143.32. And then 1111 times 74.55. And so I get 0.437 grams of KCl. Okay, and now all I got to do is that last little bit, and that's kind of the easy part. So it actually, with 4 sig figs, it should be 0.4370. I forgot we were doing 4 on that. So I just take the 0.4370 over the 0.4500. I'm going to times that by 100. And then to do 4 sig figs, that's going to be 97.12%. And we can see that it's a pretty pure sample. We didn't mess that one up too bad. So if you have any questions, if you have anything you want to see me work out, just hit me an email or mention it in class.